Today, guys, like we will cover this like first hop redundancy protocol, which are HSRP and VRRP and GLB. So all these protocol guys doing the same thing. So mainly guys like we are covering in this class HSRP, and as guys like you have already my CCNP video, so you can cover like VRRP, GLBP also. But you see guys like as you are using the Cisco devices. So most of the time, guys, we will see like in your company network, they are using HSR. So first, guys, I will tell you like what these protocol do. Then I will also explain you where we use this technology. Okay. So the idea is, guys, like these three protocol, they are providing us the virtual IP and the virtual MAC. So if you see this scenario, so here, guys, like we have a two core switches, and this is like generally guys like we create a SDI interface on our core switches, and all the end machine guys, they are using this SDI IP as a gateway. Here guys like the question is, so we have a two core switch. One is, this is my core one, so it has 1.1 SDI IP address configure, and on the second core we have a IP address which is 1.2. So if we use the gateway IP on this end machine 1.1, all my traffic will go to this device. However, guys, if your core switch goes down, then the second option, guys, we need to modify our gateway IP, which is 1.2. Okay. So this is not a feasible solution. Okay. So definitely, guys, we need some virtual IP who can monitor these two core switches. Okay. So these three protocols basically provide us the virtual IP, and so in HSRP, your one core become active, and active is guys listening on this virtual IP. Okay. So all your end machine, they are using the gateway IP, this virtual IP, okay, 1.3, and let's say if you have a core one working as active, and this is your standby box. And in case if your core goes down, then this virtual IP automatically assigned to this box. Okay. So all the end machine then send the traffic to your second core and then towards to your WAN network. Okay. So this is basically the purpose of using these three protocol. Okay, all these three protocol provide us the virtual IP and the virtual MAC. So this is one scenario we use HSRP in our LAN. So let's say guys like if we have a 100 VLAN, that means we have 100 SDI configured on our core. So in each SDI, we need to enable the HSRP or either VRRP or GLBP to provide the virtual gateway IP. However, guys, these days, as I told you, if we have a technology VSS or stack. So what VSS and stack do? Okay, so these your core switches become a one core switches, and so this is the like topology once we using the VSS or uh, stacking. So your these two core switches become a logically single switch, and we don't create the two SBA interface. We will only use the one SBA interface. So in this technology, guys, like we don't require the HSRP, VRRP, GLBP. The reason, guys, like now logically we have a single core switch. Okay? So we don't have like two SBA interface. We have a single SBA interface, and those single SBA interface become a gateway IP. Okay? So in the LAN, earlier, guys, like we used to use HSRP, VRRP, or GLBP. But now, as we are using VSS or stack, we don't require HSRP or VRRP, GLBP in our LAN network. Okay. However, guys, if we see the full topology of enterprise setup, okay. So if I show you, this is my enterprise setup. Still, guys, like we require HSRP, VRRP, GLBP in this network. Like if you see, especially the WAN part. So on the firewall, this is my firewall. On the firewall, guys, like you see, like we always do the default routing, because the default routing, guys, like we require to access the internet, right? So on the firewall, if we see, if we're providing the default route, we have these two routes, okay, internet gateway. So generally, guys, like this is setup, okay, like if we have a two ISP link, one ISP link we terminate on router 1, second ISP link we terminate on router 2. So on the firewall, when we pointing the next top IP, we have a two gateway. One is this IP address. Let's say this IP address is 10.1.1.1, and this router has LAN IP address 10.1.2. So again, like the same question for the firewall. So the firewall have a two gateway IP, and if we pointing the next top IP, this let's say 10.1.1.1, and if this router goes down, or maybe this LAN interface goes down, we need to manually change the a gateway IP which is 10.1.2. So in this case, guys, definitely it's not a feasible, okay? This is a manual work, okay? So inside of this, we need a virtual IP 10.10. Let's say 254. So this is my virtual IP, and again, virtual IP, guys, like provide us these protocol, okay? HSRP, VRRP, GLVP. So that means, guys, on this LAN interface, you will configure the HSRP or either VRRP or GLVP. So that's why, guys, like you require HSRP, VRRP, GLVP, any design. When you see you have a two gateway IP, you cannot use the physical IP as a gateway IP. If one gateway goes down, then you need to manually change the next top IP. That's normally people don't want, okay? Obviously everybody want automatically failover. So in this case, guys, like you see, we require the virtual IP. So we use HSRP or VRRP or GLVP. So mainly, guys, like today we will focus on the configuration of HSRP, how this work, okay, and then obviously the troubleshooting. And once we done this, so I will also explain you like just the activity which we will perform. So even like in my current organization, they are also using HSRP. I don't know why, but I will like explain you like how we perform the activity and what was the setup. Okay. So in this case, guys, like if you see in our setup, we have a two core switches. So we're not using VSS or stacking. So that is all my end machine. They need a virtual IP, okay, as a gateway IP. So we will run the HSRP for VLAN 1 as well as for VLAN 2. Okay, so let's start the first like HSRP theory perspective, guys. So HSRP, guys, like Cisco proprietary feature. So this is Cisco like protocol, okay? So we can only run on those devices which are basically Cisco devices, okay? So in case, guys, like if we have a different vendor, then generally, guys, people are using VRRP, okay? Like let's say if you have a Juniper or Arista, any others like Dell switches, we use VRRP. So this is the key thing, okay? Make sure you know like this protocol use which transport. So HSRP, guys, this is the, if you see the OSI layer perspective, okay, this is basically the application. So this is work on layer 7 and it has the port number 1985. And on the layer 4 perspective, we have a transport protocol which is either TCP or UDP. So this is using UDP. Okay. So yeah, I see like sometimes like you apply the ACL, even like just today I faced this issue, okay? So we already apply one ACL. Make sure in the ACL you are not blocking the HSRP transport. If you let's say blocking the HSRP transport, then HSRP won't work. Okay. So this is a common issue I have seen in the real world, and maybe guys like during the interview you can explain them. Hey, I know like this is the issue I face in HSRP. Again, I'm telling you like what was the issue and how I troubleshoot. Okay. So make sure guys like you know which protocol use which transport, and if you applying any filtering, make sure guys you are allowing that transport okay to run the protocol. And then again guys like we have like one device become active and other is standby. So to like configure an active device guys like we will play with this priority value, and by default both devices have the same priority. So again it depends like which device you make up active, so you will configure the higher priority. And if the priority is high, I believe guys like the not sure highest IP or lowest IP become active. Okay, but definitely guys like for the clarification, okay, if we want our core switch become active for VLAN 1, so we will definitely configure the higher priority on a core 1. Okay, so these are the like another important question in HSRP, which is oh, what is the difference between HSRP version 1 and version 2. So definitely guys like we'll see the like we'll use the version 2. This is commonly being used. So I will also tell you what is the difference between version 2 and version 2, and then how we can achieve the load sharing in HSRP. Okay. So let's start the configuration guys on this scenario, and then I will also explain you guys like how this protocol works. Okay. The first thing guys like if you go to the core, you see like show IP interface brief. So we have two SDI configure. One is for VLAN 1 and other is for VLAN 2. Similarly on the core 2, we have a show IP interface brief. We don't have any SDI configure. Okay, let me configure the SDI. So as of now, we have two VLAN. VLAN 1 IP address 192.168.1.254.255.255 and no shutdown. One thing like guys I have seen in the new 9500. Okay, when I'm creating the SBI, by default all the SBI in shutdown state. Earlier guys like I remember only VLAN 1 in shutdown state, rest are no shutdown state. But on 9500 I've seen like when I'm creating any SBI, the default is basically they are in shutdown. So every SBI when I'm creating, we need to use this no shutdown command. So similarly guys like we interface VLAN 2 no shutdown IP address 192.168.1.254, sorry VLAN 2 2.254.255.255, and that is it guys. Okay, now we have configured the SBI interface on both the core switches, but again so VLAN 1 has no IP address. Interface VLAN 1 no shutdown IP address 192.168.1.254, and once you create the SBI, the first step like you will definitely see whether my SBI is up or not. So we can see show IP interface brief. Make sure guys like it is up. Okay. In case it is up down or down down. So I already explained you like how we do the troubleshooting for SBI interface. But this is the first step guys. Like when you're creating the SBI, make sure they are up. Okay. So now on the end device, which IP we use for a gateway IP. Okay, so if you see the command prompt, this machine, okay, this is a machine which are participating in VLAN 1, and if we see like what default gateway IP we have configured, if you go to the properties and TCP, and so we are using like physical IP 253, which is configured on a core 1. But let's say guys like I'm using the virtual IP 100. Okay, I'm using this IP as a gateway IP. This is my HSRP virtual IP. Okay, I'm doing the HSRP configuration now, but you see like all the end devices, they will use that gateway IP is a virtual IP. Okay, not the physical IP. So on the core one, the first thing I like we require to do the configuration HSRP configuration for VLAN 1. Similarly like it depends like if you have 100 VLAN, so each VLAN we need to do the HSRP configuration. Okay. So simply like we define like VLAN 1, all the HSRP configurations command start from standby. So this is the thing, okay. As I told you guys, like these days everyone using HSRP version 2, and the main reason guys, like if you see the version 1 only support the group number up to 0 to dash 255. Okay. However, guys, like if you remember, your VLAN range number is from 0 to 4095. Our 0 is reserved, and this is also reserved, guys. We cannot use these number, okay, first and last. Then we have a number is 124094. This is my VLAN range. So idea is, guys, this number not providing via HSRP version 1. If we're using the version 2, the version 2 have the exact group number range, okay, which has the VLAN, okay. So this is like basically we in version 2 normally, like I'm showing you, let's say if you're using the HSRP for VLAN 1, we always use the same number, okay, just for the clarification, okay. This is not a necessity, but I have seen like in the real world, let's say if you're configuring the HSRP for VLAN 1, we will use the HSRP group number 1. Similarly, let's say if you're creating the HSRP configuration for VLAN 10, we will use the HSRP group number 10. So this is how we design, okay, just for the clarification, okay. However, it is not necessary, but that's why guys, like version 2 support the same amount of group number which we have in VLAN range, okay. So that's the one reason. Second, I have the version 2 support IPv6 also. So on this interface, if we have a dual stacking means, guys, like on the single interface we have IPv4 address also, and we have IPv6 address also. So in this case, guys, like if you want to run the HSRP configuration for under this VLAN, we need to use HSRP version 2. Okay. So that is the difference between version 2 and version 1. So you simply need to define like standby version 2. Then you can see like standby. If you use, now we have group number range is increase. So if you don't define this command, that means you're using version 1. Okay. So standby, let's say I'm using the group number 1, and the only thing we need to first define my virtual IP, which is 1.100. Standby 1, this is the second command I'm using. So I want to like make sure for VLAN 1, this device become an active switch. So I will configure the higher priority, guys, let's say 101. So default is 100. That is it, guys. This is the minimum configuration required to enable the HSRP. So I'm going to the core 2. So this is now showing active, and on a core 2, VLAN 1, standby version 2, standby group number 1, and we are defining the virtual IP, which is 1.100. That is it. So here, guys, like we don't need to define the priority, which is by default 100. So core 1 has the higher priority, and HSRP has the the second core has a lower priority. So this means, guys, like your one device become active and the other device become a standby. So the verification command, guys, like very simple, show standby brief. This is the command I use mainly. So I will see the status, okay, on this device. If you see, this is my VLAN interface, and we are using for VLAN group 1. So this device has a priority 101, and this device working as an active. Active is local, that means I am the active device. Standby showing unknown. Still, guys, like they are figuring it, okay, like who is the standby device. This is a common issue I have seen. You see like one device showing active and the standby showing unknown. I will discuss this problem, guys. But definitely, guys, like still basically they are synchronizing, okay. Once they are properly synchronized, they will show you the standby device is 1.254, which is your core 2, okay. And this is my virtual IP. So this is a brief command, and if we run command this again, you will see now the standby IP showing 1.254, which is our core 2. And other command guys like we use show standby. This is the providing the full output. Okay. So if you see guys like I'm active and my standby router is 1.254, which is our core 2. And the reason guys like this device has the priority is 100, and on my side guys I have configured the higher priority, which is 101. By default hello time is 3 seconds, so they are communicating to each other like, hey, I am the active box, and the hold down timer is 10 seconds. So permission is disabled, and this is the thing, okay, like not only guys we are using the virtual IP, we are also using the virtual MAC. So the last two number, okay. So virtual standby one, this version 1 have different virtual MAC, and standby version 2, HSRP version 2 has a different MAC address, but the last two number defining the group number. Okay, 01 is basically defining the group number. So the idea is guys, for this PC we are using the default gateway 100. So 100, that means we are not only using the virtual IP, so we will also see the virtual MAC, which is this is the virtual MAC guys. So 00 F001. So this PC in our table, okay, we will see the default gateway, and the corresponding the MAC address will be the virtual MAC. So this device, when sending the traffic to your WAN, guys, like you see, like when we want to communicate to different network, then only we will send the request to our default gateway, right? So this PC send the traffic to this access switch. Now this access switch forwarding the traffic based on MAC addresses. For this virtual MAC, they will send the traffic to this box. Again, there is like this layer 2 communication handled via your STP protocol. I'm assuming this is my root port, okay, RP, and this is active in STP. So my traffic is going to this side, okay, which is my active box. Then this device have a maybe the default route pointer to your router. Then this router has the default route pointer to your ISP. This is how the traffic is leaving all my devices which are in VLAN. Okay. Yeah, if you have question guys, like we use single virtual IP for both switches. Yes, I'll tell you basically virtually. Yeah, definitely we will use the same virtual IP for our both switches. Okay, this is for VLAN 1. However, for VLAN 2, we use the different virtual IP because VLAN 2 has a different IP schema. Okay, so the point is, guys, like here, if this link goes down, or maybe this box goes down, then how this switch, the switch in middle, okay, how they know now I need to send the traffic this way. So earlier, guys, like this device sending the traffic to my core 1, and once this core goes down, then this device automatically move this virtual MAC to this side, okay, on this port. So this is basically the interview question, okay, I'm explaining this, okay, but right now, like if you see, it's very clear, okay, one is active, other is standby. Only the traffic will handle via the active box, okay, and the standby become a standby until we don't have any failure, okay. So this is the minimum configuration. Let me show you the configuration again. The show run interface VLAN 1. This is the minimum configuration we have configured for HSRP. And similarly, guys, like show run interface VLAN 1. Okay. The next thing, guys, like if you want to see, let's say, guys, what I'm doing, I'm showing you the failover scenario, and also we are using some debug command. Okay. So I just want to show you guys like when failover occur, okay, how the devices in middle they are start forwarding traffic to this way, okay. So you need to know. So let's say, guys, I'm using some debug command, okay. Let's say debug R, So debug standby, and let's say enter, and the debug IP are post. Okay, let's only standby is enough. Okay, now one way I simply power off this switch. Okay, let's say this device is now power off, and before power off, let me save the configuration right, and we select stop. So think like that. This now this switch is goes down. Okay, in the real world, so this switch goes down. Yeah, it's a GR concept. So if you see now on a core 2, I am become active. I am become active, and let me just stop this debug message. Okay, you all. So if you see guys, this device become active, and when this device become active, so basically guys, like as we know, they are sending the hello packet to each other. Hey, I'm the active box. Okay, so if we don't see any hello packet, we will wait to expire our hold down timer, which is 9 seconds. In 9 seconds, if I don't see any hello message, I will consider myself as an active box. And when this device become active, guys, this device also generate the Grutis ARP, which is also known as GRP. Some people say Grutis ARP, some say Grutis ARP. Okay, but what is this GRP? Okay, so this device basically, when this device become active, GRP basically is the packet which is ARP reply without any request. Okay, so when this device become active, they will ARP packet is guys broadcast packet. Okay, they will send the packet to all the link and telling the other devices, hey, if you want to reach this IP address and the MAC address, start forwarding the traffic towards to my side. Okay, then all the switches in the middle, they will, like earlier this virtual WAC, if they have an entry via this side, they will remove those entry and point the same MAC address towards to the core 2. Okay, so all the middle device guys, basically they will update the cam table based on this GR. So if you see guys, like this is basically the R packet. So we are sending, hey, so to reach this IP address and MAC address, we are sending the R packet, and as this is a broadcast packet, R packet, all the devices in the middle, they will basically update their MAC address table and sending the traffic to this box. Okay, so this is really like that happen. Okay, failover happen, and we will also see, yeah, this is a default timer, 9 or 10 seconds. It's 9 or 10. It's 9, I believe it's 9. If you see show standby brief, it's 9 point something. Okay, show standby brief. So it shows standby only. So okay, like this timer you can change. Okay, the whole, so it's 10 seconds. Sorry. This timer like you can change. You can also use BFD protocol with HSRP for the high conversion speed. But BFD guys, like we talk about later. Okay, but this is like how it works. This is how it works. So far, guys, like HSRP is only responsible for two failover scenario. So if you see, guys, let's say this is your WAN network. This is your WAN network, and we have, let's say, ISP link terminate on router 1, ISP link terminate on router 2. So this PC, guys, let's say we are sending traffic to our active box. Active core switch have a default route pointed to the router 1. Then the router 1 default route pointed to the ISP. So in this scenario, this is how this PC has the internet access. Okay, but let's say guys, like now if we see from the core perspective, if our this link goes down, which is going towards to the, this is my failover scenario 1. So as of now, the configuration layer like which we did, it will not handle via the HSR. If the WAN link goes down, the uplink which is going towards the router, as per the current configuration, this is not handled via HSRP. The second failover scenario, if the whole box goes down, then yeah, this will handle via HSRP. So what HSRP do? HSRP make this device will be active. That means this machine sending a traffic to core 2, and I am assuming core 2 have the default to towards the router 2, then the router 2 have the default to towards to the ISP. And the third failover scenario we have, let's say this is my LAN link goes down. This is the third failover scenario. This is also handled by HSRP. So only 2 and third, these two failover scenario handled by HSRP, okay, as per my current configuration. So we'll see again, like if you want to monitor your uplink, WAN link, this is also can be done via HSRP, but this is also can be done via your routing protocol or your routing design. Okay, so this design, your uplink failure, okay, or either the link is going to your router or ISP. We will see later on, like when we cover the routing. But other two failover scenario, guys, remember handle via your HSRP protocol. Okay. So let's say, guys, again we are enabling our core switch 1. Okay. So start, and if we say now this device again on or up. So as guys, like earlier, guys, like this device had an active box, okay, for VLAN 1, but by default, guys, like in HSRP, permission is disabled. I will guys tell you what is permission, okay. So what is permission, guys? Like, so in case, guys, this device become active, even this device have a lower priority 100, and this device has a higher priority. So as per the configuration, guys, this should be our active box. But as guys, like our failover happened, okay. So even though this device have a higher priority, this will not become active, okay, until we will not enable the permission, okay. So make sure, guys, like you will also use one more command. You will enable the permission, so that, guys, like in case our active box again join our network, and obviously, guys, like we have configured the higher priority, and as per our configuration, this should be the active box. But by default, as permission is disabled, it won't become active unless, guys, you will not enable the permission. So you see, guys, like still my core 2 is active because of the failover, okay, and I have the higher priority, but still I must stand by. Once your device become active, okay, it will remain active, and this state will not change, okay, even though this device has a higher priority. The reason because permission is disabled. So permission, I like basically allow to make the device active which has a higher priority, okay. The show run interface VLAN 1. The next command, guys, like we will configure on the device which has a higher priority, but generally, guys, like we'll use this permission on all the devices, okay. Stand via 1 permission. Once we enable the permission, now this device again become an active also. The show stand via brief. Okay, so yeah, this is a basic thing, okay. Like so far today, like we have discussed the configuration and some of the verification command, and we also discussed how this works, okay. Now the mainly, guys, like I told you, the issue which we see in the real world, which is especially when you seeing the both devices showing active. This is a guy like the common issue I have seen in HSRP, and this is generally, guy, like because of, let's say if you're applying the ACL and you forget to allow the transport protocol, and so accidentally guys, like basically you will break the HSRP communication, and as they are not both communicate to each other, we will see like both device will show active. So let me show you guys like this thing. Okay, like let's say guys, like right now our core is active device, and the standby is core 2. So let's say like you got some requirement, you want like all the VLAN 1 machine, they 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 only need to allow the port 80 and 443. So you just create one ACL, okay, on both the core IP access list extender VLAN internet for VLAN 1, and you said let's say permit TCP any for internet way, like we require port 80 and we require port 443. We also require DNS EQ 443, and let's say I'm only allowing those port, okay, and once we apply the ACL IP access group internet VLAN 1, okay. So this is the problem guys, like when you don't using the VSS, you make sure that like you are doing the same exact configuration on a core 1 as well as the core 2. But when you have VSS guys, like as both devices become one device, so this is also like VSS also help us for the easy management. But earlier guys, like HSRP, like as these two are individual box, okay, so we need to do the configuration, same configuration on a core 1 as well as on a core 2, okay. The same thing guys, like I'm doing the ACL on a core 2 and applying the configuration IP access list extender internet, and for VLAN 1 permit TCP any EQ 80, permit TCP any EQ 443, and we apply this ACL to interface VLAN 1 IP access list extender, IP access group, and the ACL name involved. Okay, so we have applied the ACL on both the SD interface, which is for VLAN 1. Now guys, if you see show standby brief, okay, if you this is the output of core 2 and this is the output for core 1, okay. So show standby brief. If you see guys the output of on a core 1, we are seeing core 1 showing active. So active is local, that means I am working as active. Even on the core 2 as standby showing unknown. And on the core 2, we are seeing the same output, okay. We are seeing like I am in the active box and standby unknown. So this issue is also known as split brain issue. So any failover technology guys, if the both device showing active, this is basically they are not properly communicate to each other, okay. So this is how the failover technology works, guys. So one is active, then we are sending the hello packet to each other, and we are telling, hey, I'm working as active, you will remain standby. If I goes down, the other box, they are not receiving the hello packet, they will consider ourselves as active. But you see, this is now happening, okay. Both device showing active. This is definitely like they are the middle of the devices. Sometimes you will see the MAC address is going to this way, so this way, so you will see the MAC flapping issue. Because virtual MAC, you will see sometimes this interface, sometimes this interface. You will see the abnormal connectivity, okay. Sometimes maybe the end machine they have an internet reachability, some they don't. You will figure out, hey, what is going on, okay. So you see like in HSRP both are showing active, which is not good. We need to figure out why they are not showing active standby, okay. This is a common issue I have seen. Even on last Friday when I see one of the VLAN showing the same status. Then I check they have applied the ACL. Earlier they were not using HSRP for those VLAN, but on the new switches they told me like, hey Gurpreet, can you configure the HSRP for all the VLAN? And then I did. One of the VLAN I'm seeing this issue, and I checked they applied the ACL, but in the ACL they forget to allow the HSRP transport protocol. This is guys like normally happen. Okay, you see like when you applying the ACL as HSRP require to allow UDP port 1985, and you haven't allowed this port in the ACL. When we sending the hello packet to this device, we have inbound ACL configure, and inbound ACL only allowing the port 80 and 443, and they are dropping the UDP HSRP packet. Okay. Similarly, when we are sending the hello packet, this device also have a ACL configure. When we sending the HSRP packet, they are basically blocking the traffic. Okay. So the hello packet is not receiving to both the boxes. Both boxes are showing active active. This issue is also known as active active or split brain. Split brain basically they are not able to communicate to each other. Both are split. Okay. So in order to troubleshoot this, make sure you see we are getting this issue for VLAN 1, and on VLAN this configuring any filtering. Okay, VLAN 1, and make sure as we see we have filtering configure, which is our access list. In this access list you need to know HSRP use which transport. So definitely we will allow this transport to run the HSRP. Okay, so we will also configure permit UDP any EQ 1985. This is the protocol used via HSRP, and similarly show IP interface brief, show run interface VLAN 1. This is my ACL IP access list extender. Permit UDP any EQ 1985. Once we allow this HSRP transport, now they are communicating. Okay, now we see some log message and show standby brief. Now we see active and standby box. Yeah. So any question guys, like I'm